I have a dream, that's all I need. I'll make it happen.
Hi friends, and welcome to Team Math Academy. If you have not subscribed, please don't forget to do that. Thank you. In our first series, we treated variables and its operation, where we look at multiplications of variables of different and the same variables. But this is our series 2. It's addition and subtraction of variables. How do you add and subtract variables? Addition and subtraction of variables have the same rules. To add or subtract variables, we have rules that must be considered. One of the rules is that it must have the same variable. If you want to add variables together, they must be of the same thing, that is the same letter. Number 2 is that the two variables must be in the same power. They must have the same index, the same power. That is the condition. Once they are in the same power, then you are free to add or subtract. Now, look at this number 1. Even though they have the same variables and they are not of the same power, you cannot add it. Okay, so these are the only conditions that you must follow before you can add or subtract. Number 1, they must have the same variable. It does not stop there. They must also, those variables must also be in the same power. Now, take a look at these samples. We have 2x plus 3x. This is plus, not multiplication. So 2x plus 3x. What do? You will observe here that we have x and x here. They are the same variable. That is one of the conditions. Number 1, it must have the same variable. It does not stop there. What is the power? Okay, this one is power 1. You know, I can write x raised to power 1. It also means what? X. Okay, so 3x is power 1, 2x is in power 1. Therefore, I can add. Okay, now adding what? The coefficients together and pick one of the variables alongside. So 2 plus 3, you know, it's like you have, for example, it's like you have 2 oranges. Let's assume that this x is orange. So here you have 2 oranges, okay, plus 3 oranges. Altogether, that will be what? 5 oranges. So here I have 2x plus 3x. They are the same thing. Orange and orange, they are the same. Not orange and mango. No, it's orange and orange. So everything will give you 5 oranges. So here too, I have 2 plus 3. You can do it like this. 2 plus 3. Then you pick one of the x. 2 plus 3 is what? 5. That is 5x. Okay. Number 2, x plus x. X plus x, you know, here, the coefficient of x here is 1, but it's invincible. In mathematics, we don't write 1x. It's wrong. Instead, we write x. But from 2x above, it will be shown. But if it is, you know, 1x, it will not. It will only be x. So it means that here is 1 plus 1. That is 2. And the powers are the same. What do? Pick one of them. So that is 2x. The other one here is 5x minus 3x. They are of the same power. Therefore, I can subtract. Here, I added because it's plus. But here, you know, I said it has the same rules. So you add or subtract. It's still the same thing. Addition and subtraction. So here, I'm subtracting because they have the same rules. Normal subtraction. Normal 5 minus 3 is 2. But if you look at this one, they have membership. This one is 5x and this one is what? 3x. So I have what? 5 minus 3. That's what? 2. And that is 5x minus 3. That is 2x because it has what? The same power. Look at this next question. It says 3x squared plus 4x squared. What do you observe? They have the same variable xx and also the same power. When they have the same power, then you can add it. That is the law. Okay, so that would be 3 plus 4. That will be what? 7. The reason you are adding is because they have the same power. That is it. Then what do? Pick one of the variables. That is 7s squared. This is a member. It's like you are, it's like, if I should cancel this now, I'll write what? 7s. But the membership here is squared. So it will also be squared there. If it is 3, it will be 7s raised to power 3. The next one says 8s cubed, that is raised to power 3 plus 2x raised to power, sorry, pardon me please. I wanted to write 8s squared. So 8s squared plus 2s cubed. You will observe here that this one is in power 2. This one is in power 3. Take a look at this law. It must be in the same power. But this is 2 and this is 3. That is different power. Then what do you do here when they are not of the same power? You cannot do anything. So your answer is going to be that you repeat it. There is nothing you can do. That is because a lot of students will now say 10x raised to power 5. No, please, it's not allowed. What you need to do, because that is the law, you must check their powers. So since it's not of the same power, you write it back. There is nothing you can do. So that is 8. The answer remains as 8x squared plus 2s cubed. The next is addition and subtraction of different variables. You will observe that here is x plus y, not x plus x. This one is a variable, and this is another one that is different. So what do you do when you are adding and subtracting? If it is multiplication now, x times y, it is xy. They come together. If you remember the first series. But here, addition says the first law says that they must have the same variable, but they do not have the same variable. So what do? You write it back. So that would be x plus y. That is the answer. There is nothing you can do. The same thing is applicable here. A minus b. They are not the same thing. Okay, so you write it back. Look at this one. 2s squared plus 3y squared. They have the same power. Fine. But the variables are not the same. There is nothing you can do. Those two laws must work together. So what do? You write it back. 2s squared plus 3y squared. Take a look at this. 6x raised to power 5 minus 4x raised to power 5. Yes, they have the same variable and the same power. Therefore, you are free to go. You can add or subtract. But here is subtraction. So 6 minus 4 is what? That is 2. Then 2 what? 2x raised to power 5. So that is 2x raised to power of what? Of 5. Now, take a look at this. mn plus mn. If you ask some students this question, they will tell you that it is m square n square. No. This mn, this is addition. Okay, these variables here have become 1. mn. Also here, mn is like you say s plus s, that is 2x. So mn plus mn is 2, that is the coefficient here is 1, 1. In addition and subtraction, if the laws are now, if you have passed the law that they have the same variable and equal powers, what you need to do is that you add or subtract their coefficient as the case may be. Okay, that is it. But here the coefficient here is 1, 1. That is 1 plus 1 is what? That is 2mn. That's it. Then the next one, if you look at it carefully, that's why you need to study this thing very well. We have 6xy squared minus 3xy squared. If you observe well, you will see that they are the same thing. We have xy squared. Okay, also here, xy squared. They are the same. Then what do? You say 6. Now you are free to subtract. 6 minus 3, that is 3. Then you pick one of them because they are the same thing. They have the same variable and they have joined together now to be 1. Okay, so that is the same variable. And the next one says 7 minus 5. I know it's 2, but look at this one. This one is x square, y square, y. It's not the same anymore. It's not more the same thing. Okay, this variable, the power here is 1, here is 2. Okay, let's come back to this one. The power here is 1, here 2 is 1. Power here is 2. 2 is the same thing. But here, power here is 1, here is 2. Power here is 2, here is 1. They are not the same. Therefore, you write it back. Okay, still on addition and subtraction of variables. The next one is 5p plus 3p square. Although they have the same variables, okay, but the number 2 is very, very important. That even though they have the same variable, they must also have the same power. But you will observe that this power here is power 1, okay, but here is power 2. So the powers are not the same. Therefore, you cannot do anything. What do? You write it back. That is the law. Then look at this one, 10a minus 5b. Automatically, this one, they are not even the same thing. So you write it back. Look at this, 8m cube minus 2n cube. Okay, even though they have the same power, but is the variables, that is the letters, are not the same. So what do? We write it back. So 8m cube minus 2n cube. Look at the next one. The next one is 6s square y cube plus 4s square y cube. Take a look at the powers here. S square, the same thing. Y cube, the same thing. Then you are free to go. But if this one here is like 2, although here is s square, then y cube, y square. This one has scattered everything. There is nothing you can do there. Okay, you will have to write it back again. But because this one here is cube, the same thing, then you are free to go. You can now add 6 plus 4. That is the condition for addition and subtraction. If it is minus, you subtract. So 10x is power 2, then y is power 3. Look at the next one. 5 kr, the same thing, the same powers. Okay, so what do? You subtract. 5 minus 3 is what? 2 kr. Okay, and this one is 13m raised to power 5 minus 10m raised to power 5. So what do? 13 minus 10 is 3. Because they are the same power, that's why I'm solving it. So m raised to power 5, m raised to power 5. What do you say? We write it out. So from here we can solve it because they have the same variable and of the same power. Okay, here is 8m squared minus 7m squared. They have the same variable and the same power. Then you are free to go because equal. So 8 minus 7 is 1. But you know, in mathematics, we don't write 1m wherever. It's supposed to be m square actually, but we cannot say 1m square. It's not allowed to write 1. Instead of writing 1, we write only the letter. In mathematics, when you write only the letter, it means it is 1. But starting from 2x, it will show. Although 1 is there, but it's invincible. It must not be shown, except if it starts from 2 upwards. So 8 minus 7 is, I know it's 1, but I can't write the 1 here with the letter. It's not allowed. Instead, I write m raised to power 2. Now, the next one is 3k plus 2kr. This one should have been possible, but because of this r, there's no r here. So they are not the same thing, not the same variable. Kr, not the same thing. There is no partial in mathematics. Okay, there are some people that will write 5kr. It's not allowed here. Math should be perfect. So 3, you write it back, 3k plus 2kr. The next one is 4y cubed minus 3y squared. although it has the same variable, but the powers are not the same. That is the only condition to solve. So this one is power 2, power 3. You can't do anything. Then you write it what? Back. So as 3y squared. Then here 5xy plus 3xy. Although this one is, sorry, I mean 3x squared y. So I mean here is xy, the same variable. But this one, there is a square here, a power. This one does not have. Okay, in each of the variable, this is what I'm trying to say. In each of the variable, okay, the powers must be equal with one another. In fact, with the whole thing. Is that understood? Like this one now. This one must be the same thing with this one. For this one, if they have the same variable, but the powers too must be equal. Look at this one. They have the same variable with this one, but their powers is not the same. So that must correspond to each other. Okay, so that's why there is nothing we can do there. This one has scattered it. Therefore, we write it back. Now, the reason I am teaching variable is to make mathematics easy when we get to other topics in mathematics. Because if you are going to come across all these things, when you see this one and we say m squared, you will not be wondering why we get m squared. Okay, so this is the time to really study and study. You can go over the study again and watch all over again, so that you can have adequate knowledge of the topic. I believe it is well explained. Welcome back. The last on series 2 is division of variables. When we talk of division, is dividing numbers. It's still the same thing, okay, with the normal division that you know. So if you come across all these things, 25s cubed divided by 5s squared, the only law here is to divide. Okay, it's not like the addition and subtraction or multiplication of variables. It is different. This is division. We need to divide. Then how do we divide? You can see that this is the question. Okay, I now bring it back here to the using the division sign of this. I mean like this, turning it from this, although they are still the same division sign. So, but I turn it to this so that division can take place. So here I can split it. 25 times x here is 3. So that will be x times x times x over this one will be 5 times x here is 2 times x, so that the letter can cancel each other. So s can cancel s can cancel s, number will cancel number. 5 here 1, 5 in 25 is 5 times. If you divide it, you count 25 divided by 5, you have 5. So what do you have left? We want to write what we have left. So we have 5 times, what is left now? We have not divided this. Cancel, I mean 5 times x. There is nothing here. All this one has been cancelled. So 5 times x is the remaining one, and that is what? 5x. That is the answer. The answer of this is 5x. Number 2, 48s squared y raised to power 4 divided by this. So I brought it to this place and divide it. This divided by this. So what do? You will split them. That will be 48 times s, times s in 2 places, pardon me, times y, that is in 4 places. Then you do the denominator, 16 here, s is 3 here, then y is 2 times y times y cancel y cancel y, there's no y to cancel, so you stop. But let's see the s cancel s cancel s, number can cancel each other. Okay, 2 here 8, if you don't know how to do it straight, 2 in 4 is 2, 2 in 8 is 4, so we have 24 over 8. Okay, 24 times what do you have left? No, I think it's only 2y times y over, here we have 8 times, how many? Yes, it's only x that is here now. So, but if you look at this 8 and 24, 2 can still bring them down. So 2 here is 4, 2 in 2, sorry, let me do it one by one. 2 in 2 is 1, 2 here is 2, so that is 12. 2 can still go between 4 and 12. In fact, 4 can go into 12, but just let me break it down. 2 here is 2, 2 in 12 is 6 times. 6 and 2, 2 can still go. So 2 here 1, 2 here what? 3. So at the end of the day we have here 3 times y over x. Now this one has gone. 1 times x is cs. So here we now have 3 y times y is y squared. So 3 times y, that will be 3y squared. You know, you remember the multiplication of the same variable. You have y times y, they are the same thing. You pick one and represent the number of times it appears as a power. So that is 3y squared over what? X. That is the final answer.
I hope you guys enjoyed the video.
I hope you have subscribed to the channel.
And if you have not, please consider it.
And don't forget to like, share, and turn on the notification bell so you can see more of our latest videos. Thank you.